All right, here with a quick video on how to represent iterators via a method described in Sequoia's textbook chapter. Check this out if you need further reference. Anyways, in the chapter starts off with this nice little visual of sort of roughly what's going on. So we have these iterables, and when you call iter on, say, an iterable, that's how you get iterators. And in terms of getting elements out of these, we're going to access these via indexing, for instance, like list 1, list 2, get elements of those indices. Whereas with iterators, where say we have it equals iter of a list, we access the next value using next, right? One at a time. All right. So to get right into it, how we represent these in environment diagrams, well, so we have list. This is nothing new. All right, 0, 1, 2. And then we have I. Okay, well, what's I going to be bound to? Well, we're calling iter on list, sort of like what we did here. So iter on list, which should give us an iterator. And how we're going to represent that is, as we see here, we will create an iterator object or an iterator. Let's just go with iterator object. Right? It's created, and then I will be bound to that because that's what iter returns. And so when we call next of and so the iterator object actually starts off pointing to this index, this line right here, and the next index is this, the next index is here. We'll see what that means in a moment. Let me make that clear. All right, so next I, well, we're going to advance our iterator, and then what that will give us is this, the 0, because that's what we passed over. And so next I would give us 0. And so this is sort of an edge case. So yeah, if we had next I, it would give us 0. Hopefully that makes sense. But the edge case comes when, okay, we have list.append 3. Well, just as we used to do before this iterator business, we will just we will mutate list. And so the third element will become 3. And so when we call next of I, that should so we'll go here and we'll get 1, and then next of I again we'll get 2. It's not asking what it displays, but finally we call it the last time, we'll actually get 3 at the very end. I guess that's what they wanted. So it was like, oh, well, it should. Does this affect things? Yes. The iterator had no idea the mutation happened, and so it just did what it was doing. The iterator's job is to keep track of these indices so that it knows what the next element it should spit out is. Oh, that was the first example. And here's the next example. So we have, again, list 0, 1, 2. Why does that look so weird? Okay. And then I will be bound to an iterator object, just like last time. Starts off in the beginning. Okay. And so we have next of I. And so we're progressing. We put the indices. And so it's not asking for what displays, but that this iterator would have returned 0 in that case. Okay, and so here's the edge case. The next edge case is, okay, we have a list equals list plus 3. Well, we know that this, because it's list concatenation, creates a new list. So let's draw a new list. 0, 1, 2, 3. And so list is going to be rebound to that. Okay, well, list value, which is a pointer now, will now be another pointer. Okay, and if we call next I, well, I is still keeping track of where it was in this old list that is now unnamed. But in any case, we'll keep going. And so that will be return 1 in that case. For this next I, we're going to get 2. And if we try to do it again, we're at the end. And so as we can see here, we're pointing at this last index, and we should get a stop iteration error. Exception, whatever you want to call it. All right. So hope that makes sense. Here, just like before, list is being rebound to a new list. However, our iterator object is keeping track of the old list, and because that's what was passed in up here. And so I hope that makes sense. And cool.